and now consecutive motion known as uniformly variable motion. We know that this motion takes place when the velocity changes. In order to describe this motion, again we need to use some quantities. This time we have acceleration a, initial velocity v0, final velocity v, and the increment in velocity or the change in velocity delta v. The definition of the acceleration is over here. A equals delta v over delta t. So this is the change in velocity over the change in time. The symbol delta over here and here means that we need to subtract the final and the initial value, or the greater and the smaller. Same here, for example, delta v equals v minus v0, v final or terminal minus v0, v0 initial. After plugging in v minus v0 over here instead of delta v, we have this form, and this form can serve us to calculate, for example, the final or the initial velocity. Let's say we are looking for the final. So in order to find the final, we need to multiply both sides by delta t, which gives us a times delta t equals v minus v0. And now carry over negative v0 onto the left hand side of this equation, yielding the terminal velocity v equals v0 plus a times delta t. In general, instead of plus, we can take minus. So this is a general form, plus when we are dealing with the accelerated motion, minus when retarded. At any time, again, if we have a formula, such a formula represents a function, mathematical function, so we can plot a graph. Let's plot some graphs, velocity versus time, or velocity as a function of the time. Having had the function v equals v0 plus minus a delta t, we can plot a number of graphs. Velocity is the function of the time, and as you see over here, we have a number of straight lines like this one, or this, and this one. Everything depends on the parameters. Let's take into account this line. This line is drawn if the initial velocity is 0 and a acceleration is greater than 0. The slope is positive. This line, for instance, we can plot if the initial velocity v0 is not equal to 0, but the acceleration equals 0. It means that this line represents our previous known motion, the uniform motion. Also, this line, if initial velocity is not equal to 0 and the acceleration is less than 0, the slope is negative. This line, if the initial velocity is not equal to 0 and acceleration is greater than 0, As you remember, we can take a graph and whatever we can find under the graph, that field, that area, represents the distance covered by the body. So let's take any of these graphs, for example this one, and draw it again. It's drawn over here, and what we can see under this graph, this area represents the distance traveled by the body. We can notice that this figure, a trapezium, can be divided for simplification into a rectangle and a triangle. So in order to find the total distance traveled by the body, we need to calculate the triangle area and the triangle area and the rectangle area over here, and add them up. It's written over here. As you know, in order to find the rectangle area, one needs to multiply one side by another. This side equals delta t, or time of observation. This one equals v0. So we need to multiply v0 times delta t, which yields the rectangle area. Now, the triangle. In order to find the triangle area, we need to multiply the base by the height and divide it by 2. The base is again equal delta t, and the height is v minus v0, which is written over here. But from the previous conversions, we remember that v minus v0 equals a times delta t. After multiplication, we receive a times delta t squared. So h2 equals a times delta t squared over 2. Now let's substitute s1 with this term, s2 with the term like this, but instead of v minus v0 we have a times delta t, as we said. So altogether we have a times delta t squared over 2, which is written in here. And this formula is the introductory formula which enables us to calculate the distance in this motion. More precisely speaking, we see here the positive sign, but equally well we can imagine a negative one, like here. Everything depends on what motion do we have, what motion are we dealing with. And again, if plus, then accelerated motion. If minus, then retarded one. And one more thing, a certain simplification. If we consider a motion where the initial velocity is equal to 0, okay, initial velocity is equal to 0, then 0 times anything is 0, and this term disappears. What remains is only this, which is written in here. So this is a special situation where the initial velocity equals 0. But in general, this formula is applicable in order to find the distance covered by an object which is moving in accelerated or retarded motion, in general variable motion. So by this means we have found formulas or equations that enable us to find the basic quantities describing this motion, namely acceleration, initial and final velocity, and the distance traveled in this motion.